Hi everyone. I'm going to explain in this video what are linear equations and how to solve them. But first of all, let us explain what is meant by an equation. An expression is called equation if it contains two sides. So any two-sided expression is called an equation, something like A equals to B. So whenever you have two sides in an expression, it is called an equation. Next, what is meant by solving an equation is to find the value of some variable in the equation. So for example, you might have something like 3x plus 2 into 1 minus 5x, let's say, is equal to 10x plus 3. So that is an equation where the variable is x, and solving this equation means that I have to find the value of x. Now we can define when do we call an equation linear. An equation is called linear if and only if the only exponents of the variable in this equation are 0 and 1. For example, if you have something like this, we notice that all the terms contain either x to the power of 1 or do not contain any x. Or in other words, it contains x to the power of 0. Of course, we don't have to write x to the power of 0, but I'm just explaining that the only exponents are either 0 or 1. So that is simply what a linear equation is. Now, regarding the geometric significance, I'm going to dedicate another video for that. In this video, I'm just going to show you how to solve an equation. Alright, now when I solve an equation, I will end up with one of the following three cases. I will either end up with an equation with a unique solution, so we'll only have one solution, or you might have infinitely many solutions, or no solutions at all. I'm going to show you examples on each of these three cases. In example 1, we have 3 into 2x plus 1 is equal to 5x minus 4. So the idea of solving an equation is simply to put all the terms containing the variable on one side and group all the terms which do not contain the variable on the other side. Let me show you what I mean by that. First, I have to distribute, so this becomes 6x plus 3 is equal to 5x minus 4. Now I have to move the 5x to the left side in order to group all the x's together, and I have to move the 3 on the right side in order to put all the terms not containing an x together. But whenever I move any term from one side to another side, I must change its sign. So I copy the 6x, then I move the plus 5x to the other side, which becomes negative 5x equals, we copy the negative 4, then I move the 3 to the other side, which becomes negative 3. After, we perform 6x minus 5x, and that is 1x, or simply x, equal to negative 4 minus 3 minus 7. So here we ended up with x equal to minus 7. That's the only solution for this equation. So this equation has a unique solution. In exercise 2, we repeat the same scenario, but here we have denominators. In general, if there is a way to get rid of all the denominators, it'll be faster and easier. Can I do that? The answer is yes. So the first thing I have to do is to look for a number which is divisible by all the denominators at the same time. And in this case, it is 30. So I multiply the entire equation by 30, which means 30 multiplied by the first term minus 30 multiplied by the second term is equal to 30 multiplied by this term 3x plus 4 over 5. Now, as we said, 30 is divisible by all the denominators. So 30 divided by 3, I'm left with 10. 30 divided by 2 is 15. And 30 divided by 5 is equal to 6. And the equation is now transformed into the following form, which is more friendly, if you will. So we have no denominators here. Now I repeat the same scenario where I have to group all the x's on one side and all the terms not containing x on the other side. So this becomes like this. We can add the 20x with the negative 15x, which gives 5x, as well as the 10 and the 75, which gives 85. And we just copy the right side. And now we group all the x's together and all the numbers together, which gives negative 13x equal to negative 61. I need to isolate the x, which means I have to divide both sides by negative 13. And the final answer is x equals to 61 over 13. We continue with exercise 3. So here we can write the equation as x over 8 equals to 5x plus 1 over 40. Why can I do that? Simply because I can think of it as 1 over 8 times x over 1. So I multiply the top by the top and the bottom by the bottom. This is why it becomes x over 8. Similarly, I can put 5x plus 1 over 1. So I multiply 1 by 5x plus 1, which is itself, and 40 by 1, which is 40. Next, we either apply the same method in number 2, which means I find a number which is divisible by all the denominators, or I can cross multiply, which is faster in this case, but it's up to you. You can either use cross multiplying, or you can multiply the entire equation by a number which is divisible by both 8 and 40 at the same time, and of course you're gonna get the same answer. So here 40 times x equals 8 into 5x plus 1. Let's simplify now. So 40x is equal to 40x plus 8. We move the 40x to the other side, so it becomes 40x minus 40x is equal to 8. And look what happened here. We ended up with 0 equal 8. And of course, it's not possible for 0 to be equal to 8. What does this mean? This means that this equation has no solution. There is no real number x which satisfies this equation. Let's continue with number 4 now. So we simplify, we put all the x's on one side and all the terms with no x on the other side. And here we end up with 0 equals to 0. Now, is it wrong to say 0 is equal to 0? It's not wrong, it's always true. So the difference between number 3 and number 4 is that in number 3, it is always wrong to have 0 equals to 8, which gives no solution. However, in number 4, it is always true to say 0 equal to 0. What does it mean to say that it's always true? This means we have infinitely many solutions. No matter which x you plug it into the equation, it's going to work. That's the case when you end up with a right answer like 0 equal to 0, 4 equal to 4. So we end up with infinitely many solutions. And this is simply how we solve linear equations. In the next video, I'm going to explain how to solve quadratic equations. And first of all, what is meant by quadratic, what is meant by discriminant. So I'm going to explain all these terms and of course solve some examples.